Well, welcome all of Miyamoto and Miyamoto recording people. Got a good crowd in Sacramento. So today's talk is about things that can go wrong and how to make sure they don't. I've got actually 3 case studies of lessons learned, things that we've worked through projects, and they're actual examples. I will show some actual project stuff. I won't mention any project names or any people's names because it doesn't really matter. Maybe one I might. There was a Savior one that we didn't really have any culpability in, but we were heavily part of the solution. And I think this is important to share a lot of this information because every project we do is unique. It has its own set of decisions and its own set of things that can go wrong. And we have a pretty good process for performing our work and checking our work and making sure that things don't go wrong. So that's kind of what this talk is all about. So agenda, like I said, three case studies. We'll talk about a concrete podium slab that we had some challenges with. Ultimately, we didn't. Some concrete congestion concerns, and then a project where we had some dimensions on our drawings that we didn't need to have, and I can talk about why we should have those and why we shouldn't have those, and what we can do to not have that sort of thing come up in the future. So, clicker working? There we go. So concrete podium slab. Actually, let me skip forward first. This is a podium slab. It's got a lot of complexity to it. I don't know. I think you can see this whole screen. This part is actually a little amenities building on the slab, and then there's a step, and then there's a pool, and there's an amenities deck, and there's everything you can imagine in this thing. And there was a ton of different load cases and a ton of different things going on. So there's a lot of complexity. And this is a project that we were super busy at the time. And I think there were 3 offices involved. It started in one office. It got designed. The podium got designed in another office. Then it went out and it was done. Then it came back and there were some changes made, and the original engineers are no longer available. So it went to another office, and another engineer kind of did the redesign, and that engineer is no longer with us. So I could talk about them, but I won't. So anyway, there are a lot of dead loads with landscaping, pool, paving systems, building, live loads, all kinds of dead loads you can imagine. Anyway, so when this project went out, for construction, I don't think it got fully sensei'd before it went out. And then when it came back in the shop drawing process of the construction, our principal in charge, kind of their bat sense was tingling, and that I'm not sure this has been fully vetted and gone through our process. So, so they asked for somebody to take another look at it before we, reviewed and approved the shop drawings and sent them back. Well, so we did that, sure enough, and that turns out a problem was caught, and that, this is the stuff here. Come on. Kind of in this area, all the load combinations weren't correct. All the loads were in the model, and the engineer did the model, they did the analysis, and they took the output and they put what output they had onto the drawing. So, the controlling gravity stuff, as we went back and re-reviewed the model, was that 1.2 dead plus E was controlling the gravity design. And if you'd seen that or taken a critical look at that, you would have said, gee, that just doesn't sound right, because I would expect 1.2 dead plus 1.6 live would be the controlling gravity case for all the slab, the shears, the long-term deformations, and the bending moments and all that. So anyway, this is what it looked like when it first went out. Come on. And these are all the changes that we made. Essentially we added a lot of rebar in here, and this is probably too small for everybody to see in great detail, but the ideas are that we didn't really look at this in a critical manner before we went ahead and put a bunch of stuff in a model, and we took the answers and we took them as gospel, and we didn't make sure that they're correct. So we added a bunch of rebar in here, and we were all concerned that that's a big problem because it's kind of late in the game. We're in construction, and ultimately our PIC got on the phone with our client, and shared what was going on and what we were finding, and resolved the issue. And I think everything, at the end of the day, I think everybody was grateful because we communicated, and our process caught this I don't want to call it an error, but it caught this this anomaly before it got built. It's not really a problem until it gets built, but we do have a process. Our process is design correctly, sensei, send it out, have it plan reviewed, coordinate the plan review process, and then review through the shop drawing process and construction to make sure our design intent is picked up. And that's kind of our last chance to catch anything before it gets built. So how we could have avoided this, and when this came out, the principal called me and said, hey, can you help us out and look at this? And I got on the phone with our other engineer, and what I did, just kind of took quickly what we had, and I just did a smear load of the dead loads, smear load of the live loads, because we kind of knew it. Those are simple. I did a quick direct design calc. It's at ACI, chapter 8.10 now. The ACI that I use is a different chapter because I'm not on the 14. I don't even know where stuff is in there. But anyway, in the simple moment coefficients, WL squared over 11 on the interior span, that 14 or 16 on the positive moment. And if you do a simple calc with that, if you do the direct design moment method, where when I did a lot of slabs by hand when I was young. So oh, hey, sorry. If you are sitting in an office, can you mute your phone? Apparently you can hear in some of the other offices. So if you could mute your phones, that'd be great. When I did a lot of slabs by hand, 100 years ago, we used a lot of the direct design method, and it's pretty simple and it's pretty quick. I think in 10 minutes, I did a calc of this, and through 65% of the total, column and middle strip moment into the column strip, did the moment coefficients, come up with a negative and positive bending wear, check what the steel should be. I was within like 5% of what we ultimately wound up doing. So I think, when you're starting to do calcs and they're complex and they're models and there's stuff, don't just throw a bunch of stuff into the model and expect a good answer. You should kind of have a good idea what the answer is going to be. And if it looks wrong, that's where the thing, I think, with young engineers, they don't know what the answer looks like at the end, but there's simple, easy ways to kind of check. Another check I always like to know where I am as far as row minimum, right? Row minimum's 200 over FY. You can quickly multiply that by your width and your depth and come up with what a row you should have as a row minimum. Now, ACI lets you go below row minimum, but if you do, you should understand exactly where you are and why you're doing it. So I think some of this stuff is pretty simple and it's pretty clean. And I think the other problem with this thing is, an engineer was given a task in a different office, and communication probably could have gotten better, and that engineer thought they were just doing one specific assigned to them only task, and they said, that's what I'm going to do, and I'm going to give it back, and I'm done. But I think, we're better than that. If you're assigned to work on a project, you are a part of the project team, you own the project. So if you take that away as a thought, you become part of the responsible party. So if something doesn't look right, and you see it, make sure you bring up something. Anyway, so let's back the challenges that were involved in this guy. And ultimately, we caught everything got built correctly, and it's actually a pretty successful project now. And it looks quite nice. This is another one that came up in, I'll have to admit that I was involved in this because it's a parking structure. This is an issue that we really had no culpability in, but it's something I think we should, I just thought I'd share because we spent a lot of time figuring this stuff out and dealing with a contractor. It was a design build project. We were working with a contractor. There's a rebar sub, there's a concrete sub, and boy, we spent a lot of time figuring out what the heck was going on here. There's a situation essentially I think they'd done a couple deck pours and they started finding some cracking in the bottom of the beams. This is right in the exact mid span of the beams where the tendons are at the bottom, the rebar is at the bottom. And if you can see this little gray strip right here, that was really the culprit to all our problems. And I think this is pretty common in parking structure design and construction, or at least the construction side, because it's easy for the contractors to do. And what I found is this is what they do. The little gray plastic forms, they're slab bolsters. You know, I think this doesn't move quick enough for me. You know, they basically place these slab bolsters linearly in the bottom of the beams. So what that meant was the concrete was not able to flow, you know, past the bolsters into the center of the beam where the strands were low. And this was kind of a unique situation in that, you know, our spans were a little bit larger in this parking structure because they had an accessibility aisle they had to run in front of the cars. Normally we don't do that. So they were, you know, the spans were 5 feet longer and our bay widths were, you know, a foot wider than normal. So the beams were pretty heavy with, you know, we had 15 strands of PT in these guys. Typically we'll have 12. And then they'll stack the strands, you know, in 4, you know, couples of 4. So there's plenty of room for the concrete to flow around. Another issue we had was, you know, the guy in the field, the rebar guy, they use these little chairs that they tie to the stirrups. They made those number 5, so they had a pretty good bend in them. So that pushed the strands closer together, and you know, when all was said and done, the 2 bottom rebars that are the mild steel, you know, it basically became a barrier at the top of the reinforcing, so the concrete couldn't get, you know, down into this area in the center of the beam. And it was only for, you know, a 3 or 4 foot section, but that area was completely blocked with the bolsters. So things to be aware of. This really wasn't, you know, none of our doing, but it was a huge problem because it's like an 860 car garage, and you know, at the end of the day, you know, they were up to they probably had 2 deck pours to go when we figured this out. So what we wound up doing, we wound up testing every beam for cracks and voids and, you know, hollow open cavities there. And yeah, yep. They started with non-destructive. If they found a cavity, they did more extensive destructing. We did non-destructive on everyone, and then they did some. Geez, I forget what the testing was. We brought a testing agency up from up north. This project had, you know, all the quality control and construction that you would expect, and it's the same subs we'd done another structure with. You know, like a year before, we had no issues with that we know of, and none are apparent today. So I don't know what changed, but and they also had you know, the owner had their own IOR on site continually, so all the inspection was going on, and you know, we did observations. We didn't see or pick up on the bolsters being there, or maybe we didn't know what that all was. You know, we're looking to make sure the rebar is in the right place, the strands look like they're in the right spot. And you know, honestly, this wasn't visible, you know, where those things were, but you know, at the end of the day, these guys, these bolsters, as you can see, I mean, you can't really flow concrete past those, and these are long and linear. They're kind of the whole length of the beam. They're really intended for use in slabs only, where there's, you know, very minimal congestion. There's always access on each side, and they work great in slabs where there's no rebar density or blockage. But I just thought I'd share that because it was a huge problem. I bet we spent 80 hours worth of our time just in the whole time hoping we weren't going to get dragged into a lawsuit. In the end, you know, our design build contractor, who we had our contractor, they were very happy with all the stuff we did and how proactive we were. And we wrote a big dissertation and report and gave it to the client. And, you know, in the end, everybody was happy, but it was some pretty ugly times. You know, they wound up the resolution at the end of that thing, the contractor, the rebar sub, and the concrete guy just wound up divvying up all the cost of all that stuff. And, you know, we were sitting there in the room going, I hope they're not looking at us. Turns out they didn't. So we were, you know, I mean, it was a good thing at the end of the day, but we ate our labor costs. Yeah.
That report you mentioned, it'd be good to have available public.
Yeah.
Not public, but internal.
Yeah, we can share it. It was actually a pretty good and thorough document about everything that, you know, led into this, and I'd be happy to share with it. I was trying to avoid any names, but since I was involved, you know, it was basically, you know, us and our San Diego crew, and Wayne Brown actually did all the really good investigative work, and he saw a lot of the stuff through, you know, the testing, and we developed actually a pretty detailed testing program because, you know, this is a hospital project. It wasn't the parking structure wasn't OSHPD. The cooling tower that was right next door that we did was OSHPD, but and you know the structure had the same level of, you know, review, well, not plan review, but, you know, CA review. It was the same IOR, you know, that, and somehow this happened, and it was kind of unique. And you know, I talked to other people in the parking industry, and they say this is pretty common. I go, I've done a lot of structures and I haven't had this. So
Being a non-engineer, so is this something as a structural engineer that when we do another parking structure, it can be laid out to the contractors, like you cannot use this?
yeah, we have, since that's a good question. Since this issue happened, we have some notes in our typical beam details that they're not allowed to use slab bolsters anywhere in the beam. I wanted a picture of this and a big red arrow, you know, one of those things, threw it on our drawings. Now that we can print and color and most of our stuff goes in PDF, maybe we'll upgrade that a little bit. But, you know, I get why the contractors like to do that, because it's very easy. You know, they form up they form the beam cages and they drop them into the forms, and then they lay in the rebar and the strands. So it's very easy to do it. And if they can find a way to save time and save, you know, what their money, they thought they were saving their money, you know, they're going to do it. And that's, you know, contractors are pretty inventive that way as far as construction techniques. And unfortunately, we didn't, you know, get a say in this, but interesting little scenario. And, you know, at the end it was good, but, you know, along the way it was a little rough. And, you know, Wayne and I we spent a lot of time hand holding and wondering what the heck, how far is this going to go? And, you know, ultimately we found out, but, you know, we resolved it. So, but it cost us, you know, we spent a lot of time on this.
So what would be options?
Oh.
So I was just wondering, for future projects, for construction, during construction, what would be the option instead of using this bolster?
Well, they have just, you know, there's tons of ways they can chair up the rebar in a beam. You know, they have the little rebar chairs. They actually, I think what they did in the end, they turned them perpendicular to the length of the beam so the concrete could flow, you know, underneath. They could have set the rebar cages on those as if they're set transverse to the thing. I think we allowed them to do that or something, but, you know, you can't do them linearly so they block flow to the concrete. It's just something to look for and be aware of. You know, if you're doing a parking structure, make sure you're at the first deck pour and make sure that, you know, you don't have a situation like this, because if these guys figured it out, the rebar guys, I'm sure other rebar guys are using those, because they, you know, like I say, they use them for the slabs all over the place, and they had them all over the slabs and the PT decks, and so they got a lot of them sitting around, and if they got them in their truck, they're going to put them in your project. That's just how the construction industry works. So. Interesting little challenge. This was a few years ago, but we haven't forgotten about it as a learning lesson. So, yeah, I mean, the hopes of these talks is, you know, as I said, every project we do is new and intricate, and we solve unique challenges, and we don't build cars on assembly line where we build thousands and thousands of them a week and, you know, refine our process to no end. You know, so we're challenged, you know, is always finding the best ways to control quality and be aware of what we're doing, you know, and the situations that come up, they're out of our control, which is that one. So my last little case study was third-party dimensions on drawings. And this is a project that we're doing. This is actually a TI of I think it was an industrial building. Anyway, so all these dimensions that are on our plans here came from, these are basically just a bunch of paths for a bunch of equipment, some machinery, and it's highly sensitive for a manufacturing process. And these came from an AutoCAD drawing from the owner, or ultimately the client, the build-to-suit client. And the architect kind of insisted that we put these on our drawings, because they said, well, you know, we're building from your drawings. They didn't have them on their drawings, and that should have been a flag, you know, for us to say, no, we probably shouldn't do that, because normally we just refer to other people's drawings, but these actual set of dimensions and all this stuff or this really didn't reside anywhere else other than the owner's AutoCAD drawings. And there's a perfect way to do that. But anyway, our people said, well, yeah, we want to be helpful. We like to say yes. We like to resolve the problems. But this is a situation where we're basically put in position of transcribing information provided by others that doesn't appear anywhere else in the drawing set. We have great notes, on our S1 sheet to coordinate all the dimensions and stuff prior to placing any work for the contractor and coordinate between the architectural, the MEP, all this and that. Well, if these don't reside anywhere else, how can they coordinate that? Anyway, this is a design build project too. And we're working with a contractor who also has in-house architecture. So when they discovered there was a problem in one of these dimensions, and the dimension was actually this one. This height of these little pads should have been 5'0.25". It somehow got transcribed to 5'3". Obviously the person doing it, said, 3 inches is 0.25. So somehow it didn't get transcribed rightly. And any one of us could have made that mistake. And I would expect if that was the only one that happened out of all those dimensions, there were a lot more on the plan than just that. That was the only one that was wrong. So, there's a pretty good chance that we're probably not going to get all those right. And there's no reason for us to do that. Typically we would just say something max, blah, 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 or whatever, like we did here, anyway, they were supplied, I think if I'd gotten involved in this earlier, I would probably have said, or if anyone sees this and we're in a position where people are asking us to put dimensions on our drawings, like just came up this morning with another project, let's just say no thank you. And the resolution to that is, the owner had they had AutoCAD drawings with all that information on it, and those could have been inserted in the set for reference only if the architect didn't want to do it. And they could have done it, and it doesn't really need to reside on our plan because really there's no value to any of that information structurally. We don't control it. All we are the secretaries of those dimensions once we start putting that stuff on our drawings. And if things change, we're not likely to hear about that along the way, or we're likely to make a innocent error like this. I mean, like I said, this is an error anyone in this room or anyone in this company could have made. I probably would have made 10 of those errors, and just copying stuff over. So it's just a position we don't need to put ourselves in. So if that comes up, and it does once in a while, don't say yes to everything. Sorry, Tim. Anyway, lessons learned. Well, we could. Well, that's the thing. You find a resolution to it. If we threw those drawings in there as a for reference only drawing, then all this stuff is taken care of, and you have all the accurate information. If it changes, you go to the source, and you have a way to do it correctly. Just don't put ourselves in a position, which is kind of this bullet point anyway. So, yeah, that's kind of it. Any questions on that? Any questions from any of the other offices? Now that everybody's muted, it's hard to ask questions. Soon Min's got one.
I have a question. Back to.
Right.
Excuse me. Is that on? Yeah. Hello, this is Sun Min from Sacramento office. So back to the first case study.
Yeah.
So it seems like we ended up adding a lot more rebars during our shop drawing review process. And then you mentioned that you communicate with the team and it got resolved. But it seems like there would have been a lot of big change order. But how did we, I guess my question is, how did we communicate with the team to avoid any more issue?
Well, I think that's a really good question. I mean, obviously, yeah, we added a bunch of rebar. In some areas we took rebar away. So, we found some areas were wrong on one direction, some areas are wrong on the other. Ultimately, it was an add. So, but I think the communication to the client was, well, this is what happened. Here's where we're at. If this had been bid originally, you would have paid for this stuff anyway. And at the end, nobody was really upset about it. Because I mean, they obviously they wanted the rebar in the slab. We actually even wound up camering some of the slabs too, because the long-term deflection calculation was kind of inaccurate that was done at the time. So we kind of figured that out. And they don't love to camber slabs because it's not easy for them in the formwork. But if they need to do it, they need to do it. It's not unusual. But yeah, I mean, no one was unreceptive to the change. And with the discussion that this is something that should have been in the original number anyway, and you should have paid for this anyway. Luckily this one, it wasn't so bad. So, I mean, there's other people that take a different tact with that. I mean, the dimension thing, I was going to say the ARC contract was with the contractor, who's also the architect. And when that came up, they basically had to chip one of those pads down. It was 2 3/4 high, and they had an estimate of like $15,000, and they wanted to charge us for it. We're going, yeah, no. There was some other circumstances with that one too. I mean, basically they didn't check any of those dimensions against anything that was available, although they had nothing available, although they did actually have the owner's drawings. They didn't submit to a shop drawings. They didn't submit rebar shops. So we didn't really have a way to check any of that stuff like we did on the Podium one. So ultimately, we didn't charge them for our time to develop the repair. That's about where it ended. So, but they were not happy, but because it's an interesting scenario because they're contractors. They tend to deal with design professionals like they deal with subs. Beat up the subs. Well, if you think about our scenario, in something like that, our fee is probably, if it's 1% of the construction cost, our profit is maybe 10%. So we're at 0.1% of the construction cost. We're going to put that at risk against 100% of the construction cost. You could never stay in business. And ultimately we had a contract in place with them that had a resolution process involved in it, and that wasn't within it. So we donated our time to develop a detail to fix it. Which was, maybe 3 hours worth of time. But yeah. Anything from anyone else? So I'll leave you with this quote. All these are good learning experiences. I really like this quote. It was from Veronica's husband in Reno, Tony. So thank you, Tony, for your No, that's not actually Tony. Questions, we already did questions. If there's no more, that's it. Thank you all. Hope you learned something valuable. So go out, feel free to go out and make new mistakes. Don't make any of these again.
Thank you very much, Jeff. Thank you.
All right, we're done.